I think one of the crucial components in the whole mix is people. Ultimately, it's the people who drive things forward. Ultimately, it's the people who make those decisions and are responsible for business outcomes, making critical decisions along the way using the data.
You are now tuned into the MECE Muse Unplugged, a pop-up podcast variety show helping consultants along their journey to greatness with your host, management consultant, author and blogger, Christy Lindor.
Hey, my go-getters. Welcome to the MECE Muse Unplugged podcast show. I'm your host, Christy Lindor. Super excited to be bringing you episode 34. And today we're actually going to do a quick wins interview. If this is your first time tuning in, quick wins is when I have an opportunity to connect with individuals discussing ideas, products, or services to help round out your consulting toolkit. Today's guest, super psyched, we've got Biren Gandhi. A little bit about Biren. He's actually a technology senior executive, worked for a lot of cool companies, such as Facebook and other tech firms. And Biren is actually going to help facilitate what I call a disruptive technologies one-on-one conversation. I've had a lot of mentees and actually some go-getters that have, really been having conversations about all these cool technologies that's coming, that's really hitting the marketplace. A lot of noise in the system around AI, artificial intelligence, around blockchain, around, kind of AR, VR, cloud computing. So Biren actually came on the show really graciously and really starting to kind of break these down. He has a front seat as, one of the tech senior executives really helping drive this type of technology forward and advancing that agenda. And so he's going to break it down for us, really get us the one-on-one. So I know that you will find today's conversation very informative, go-getters. And we don't get a chance to even cover all of the various technologies. I've asked them to come back. So if you've got questions, thoughts, opinions on today's interview, feel free to drop me a line, mecemuseunplugged@gmail.com. Other quick updates, go-getters, want to let you know, the Amazon Kindle and Nook is available for my book, The MECE Muse. And we're still taking pre-orders. The paperback, super excited, is actually going to be released on February 20th. So make sure you do get your pre-order in. And I'll make sure we do put out the links on the show notes for you to check that out. I've gotten a lot of great feedback, a lot of positive thoughts and ideas. And so I'm super excited that people are enjoying the book. But yeah, make sure you grab your copy and be prepared for the paperback. I'm super psyched as the book launch continues to roll out. So with that, hope you enjoyed today's interview and let's get started. Biren, thank you so much for joining us today on the MECE Muse Unplugged. How are you doing?
Pretty good. My pleasure to be on the show.
Yeah, absolutely. Absolutely. And Biren, what part of the world are you sitting in right now?
I'm in the Cupertino, the sunny Silicon Valley area right now.
Oh, nice. That's such a beautiful part of California. I really love that area.
Indeed.
Well, thank you so much for making time to connect. But, before we get started with a really important conversation on disruptive technologies, maybe if you can introduce yourself to the go-getters of the MECE Muse Unplugged.
Sure, I would love to. So my name is Biren Gandhi, as you all heard. I was at Cisco for almost 7 years, doing a variety of things. And before that, in the past life, I've been fortunate to be at the pivotal spaces and pivotal stages of various interesting companies like Facebook and Zynga. And I had my own startup in between as well. So overall in Silicon Valley, focusing on a variety of things. But throughout my career, I've focused on various levels of the stack, for people especially who understand, like right from the bottom of the stack to the top of the stack, closer to the machines to more on the application and business side of the things. And as part of that, I've acquired a variety of knowledge across various verticals and domains. So, in a way it's good, in a way it's bad too, right? But we try to leverage the best part of ourselves. But most recently, what I was doing is focusing on this disruptive technologies or technologies of the future, things which are going to make a difference for us in next 5, 10, 15, 20 years. And a lot of technological buzz is going around, and sometimes it's very difficult to fine tune But what I've been doing is focusing on various aspects of engaging with technology companies in variety of capacities. Sometimes it's by investment, sometimes it's by mergers, acquisitions, doing the due diligences, sometimes by working with them in the partnership role, sometimes co-innovating, co-developing the solutions, sometimes just helping them go to market and kind of having a holding hand towards the future. But it's pretty interesting, the world and time we are living in right now.
I couldn't agree with you more on that, Biren. As you just mentioned, you have a storied background in working with, some of the most innovative companies in the world. How did you get started in this field? And, what keeps you kind of going?
Starting, I think sometimes it's a matter of destiny, honestly speaking. So at the beginning of the career, people have limited choices. And I too had the same sort of choices, right? In terms of like, where can I go depending on the skill set you have acquired by training or by your comfort zone or by whatever means. There are like some choices, but along the way, every one of us can make those specific choices which lead us into a specific direction where we want to go in. So at least having a definite goal, maybe it's an abstract goal to begin with, but having some sort of a goal of which direction or what's the end point I want to go in eventually, I think for someone who is starting their career, that's a very crucial point. And along the way, whenever there is a decision-making time, you make the decisions which are in congruence with your long-term goal. And I think that creates a path. And sometimes that path is not linear. Sometimes you might have to come back and again take the next fork in the road and go ahead with that. But I think with an open mind and open eye, people can survive and make the best use of their time in moving towards their ultimate goal.
Well said, Biren. Well, I'm glad that we're getting a chance to connect with you and that, we're going to have such a seasoned expert really give us kind of a real drill down of disruptive technologies. So I'm dubbing this episode, Biren, as Disruptive Technologies 101 because I continue to get questions from mentees or from younger consultants, hearing a lot of noise, hearing a lot of buzzwords, but really not being able to make sense of it or connect the dots. And so I think this is going to be a very popular episode. So I created, Biren, a list of different words that I know I hear or see or read about and would love for you to just kind of unpack each word for us, like what that specific technology is, and how it may be currently used today that we may not realize it. And then, as part of with each technology, if you can also share, how you believe that technology could, will impact professional services organizations or, consultants, in particular. Does that work for you?
Sure, yeah, would love to. I mean, it's all information and knowledge sharing, right? The whole world is kind of working on that shared economy, shared knowledge, and shared best practices.
Right, absolutely. Okay, awesome. I'm excited about this. So my first buzzword I see a lot is IoT, so Internet of Things. So, Biren, can you just give us an overview of what Internet of Things mean?
Absolutely. So, I mean, that's one of my favorite too, right? So it's IoT, Internet of Things. Even though there is like the word things inside the IoT, IoT is actually made up of 4 components. So it is people, process, data, and things. And each of those components have unique places. So start with things because that's most obvious is I think the world we live in, I mean, we are going ahead from the centralized computation to distributed computing as we saw the waves coming and going forward. So initially we started with like super mega supercomputers and then and we were accessing those computers with the dumb terminals. And then the era came where everything kind of switched to desktop computers and PCs. And then came, going back to the cloud computing that again centralized somewhere else, though you were not managing your own data centers. And then the wave came on the smartphones, again, moving the compute to the edge. So I think this pendulum swinging of technologies, moving the compute either in a centralized location or in a distributed location has been going on for a while in the industry as a whole. So IoT is basically making smarter things or devices or endpoints, which is they are not connected to the broader internet to leverage this connectivity paradigm, but they are getting connected slowly and steadily and having this intelligent computations running on them. So low-end devices like your temperature sensors, humidity sensors, or your door sensors or alarms or video camera monitoring, all those sensors are becoming more and more intelligent by their connectivity to the broader internet at large. So that's the things part of IoT. And 3 other components are people, process, and data. So even though it's called Internet of Things, I think one of the crucial components in the whole mix is people. Ultimately, it's the people who drive things forward. Ultimately, it's the people who make those decisions and are responsible for business outcomes, making critical decisions along the way using the data. So people are the most important component of the IoT puzzle. And also along with people and things, there are process and data. Many times we are seeing the word like data is the new oil. So essentially, all these things are starting to measure, but unless there are intelligent ways of interpreting these measurements and derive intelligence out of those. So, data is there, but it's raw data. So how do you derive knowledge and information and wisdom and make intelligent decisions based on the data using algorithms and variety of other techniques? I think that is the critical part of it. And the fourth component is the process piece of it. How do you make the workflows and processes more relevant, more meaningful? So compute was one example, like how do you place the compute wherever it makes sense logically? So for example, oil rigs, in some cases, they're generating massive amounts of data. Those little sensors are drilling for oils and various other things. But that massive data has no bandwidth to send it up to the cloud. So they are actually burning the Blu-ray discs and shipping them via helicopters to the coast. Even in 2018, 2019, if that's the way, there's something different that needs to happen. So how do we convert those legacy processes, which are highly paperwork driven or highly manual labor intensive, into more automated, more agile, more scalable processes, digitization, digital transformation of the future? So that's the fourth component of this whole IoT. But in summary, it's people, process, data, and things. They're all acting together to create a better world for us.
That's helpful. And with IoT, is the goal or the future intent that every type of utility or, every type of object is a IoT? Is that the goal? Maybe you can help with what's the end goal of all of these things, kind of going that way?
So end goal is actually making our lives better, right? So ultimately, it's all about human lives. How can we improve the quality of life? That's the overarching goal for the entire human race. And all of our endeavors are in line with that. So for IoT, it's no different. For IoT, there have been if we take just the sensors scenario, so sensors were not connected. They were locked down in some cabinet somewhere. So if something happens, let's take a simple thing of utility, electricity reading, the meters. Previously in the world, somebody from the electricity or utility company had to go out from house to house for doing those meter readings. Yes, that process worked for a while, but the computation power and the storage and the network bandwidth, they are becoming so much cheap today that it's much more efficient and much less error prone to actually let those smart meters, now as they are being replaced with. So smart meters report their reading automatically on a periodic intervals or on demand or whichever way without anybody paying a visit. So we are not only saving on tremendous human labor, but we are also removing a lot of manual errors, a lot of paperwork errors by digitization of this entire workflow. So that is a very simple example. And we could utilize actually the more intelligent, higher order human intelligence. Overall paradigm is making work more automated, more smoother, and delegating all the mundane, laborious, just routine, monotonous work to machines where they can do it more cheaply, more effectively with less errors, and use the human intelligence into the higher order needs where it makes more sense, because the human resources are becoming more and more costlier than machine resources.
Awesome. That's really, really helpful. So I'm going to actually move on to the next word here. And this one's a more broad, but AI, so artificial intelligence. So can you describe what that really means?
Sure. Yes. So far, we have heard a lot of things about human intelligence, right? But artificial intelligence is more of, again, coming to the machine era. So there are three different layers people talk about, and I take the liberty to explain two other words also in addition to the artificial intelligence. So people typically talk about artificial intelligence, machine learning, and deep learning together in some interwoven form. But so artificial intelligence, think of it as the highest level of abstraction about making the machines similarly intelligent as human beings. We are far from there yet, but I think that the number of efforts are moving in that whole overarching direction is how can we have machines think and behave similar to human beings from an intelligence perspective. So, I mean, the Googles that AlphaGo game defeating the world champions, or IBM's like chess playing computers. I mean, we have seen number of examples along the way where we are constantly trying to make machines learn faster and better and quicker than the human experts in the field. So artificial intelligence is that overarching field of making and demonstrating machine intelligence very similar or very close to human behavior or human intelligence. So that's the highest level of field. One subset of that artificial intelligence is machine learning. So that's an approach to basically achieve some of the goals of artificial intelligence. So basically you have lots and lots of data, the past data and some sort of a training set, as to speak. So you train your machine learning or computer algorithms model based on that data set that you have acquired in the past and generate some models so that it's able to do predictive modeling of the future based on the past data. So to give an example, right, like if you have last 50 years of stock market data, for example, how can you predict that a given equity or a given stock is going to move up or down in the future? If you can come up with this magic silver bullet kind of a system, that's a classic example of machine learning. So that's one way of, again, demonstrating machines, replacing human intelligence with machine in some shape or form, in maybe some limited domain. But the fundamental paradigm is learning from the past data sets and making those predictions in the future. So that can be utilized from like predictive in connecting the dots with the earlier question, IoT. When we make a machine smarter, one of the impact is coming from its machine learning also, like you acquired performance data, let's say, for example, jet engines, quick example, right? Like jet engines have been flying, they're generating massive data from various sensors. Now you have all this data set, but based on the data set, if you can predict with very high degree of confidence that, hey, when is the next maintenance, next breakage is going to happen before it actually happens. If you can predict that, hey, it's better if you do the maintenance of this jet engine now instead of next year, because some of the readings are telling me that something is wrong from a wear and tear perspective. So if you can save lives based on this predictive modeling and predictive data sets, analysis of the past data set and using it for predictive purposes, I think that's a classic application of machine learning. And the third field, even subset of machine learning, it's called deep learning. That's again a technique for implementing machine learning beyond this the predictive and all. There are like other terms, artificial neural networks and convoluted neural networks, and I won't go into the details of those things now. But that's again very specific domain of object identification, like how do you distinguish whether something is a human or an animal or some other object, and how do you define the characteristics of those objects as well, whether it's like a male or a female or some other kind of human being, or it's again much deeper than machine learning can achieve. So I think there are three different levels: artificial intelligence, then machine learning, and then deep learning. And they all pretty much rely on massive data sets, processing of massive data sets. And previously the field always existed for like last 50 plus years. But to process this massive data, the computational power, cheap computational power, electricity and other things, they were pretty much non-existent up until now. But recently they are becoming more and more accessible and feasible. Hence there is a rise in the acceleration of all these domains.
You know, that's so helpful when you kind of connect the dots of the different words and how they interact.
Today's episode is brought to you on behalf of the MECE Muse, 100 plus selected practices, unwritten rules and habits of great consultants, a book by Christy Lindor. Written in the voice of a mentor, the MECE Muse provides insights on the unwritten rules of great consultants, a perfect read for new or aspiring consultants. Christy dives into her 15 plus years of consulting experience while sharing interviews and anecdotes from over 50 consulting partners and leaders that represents thought leadership from 80% of the top 10 consulting firms in the world. Pre-sale begins shortly. Sign up at www.mecemuse.com.
My next one, Biren, is my personal favorite, blockchain. So, but if you can share kind of your thoughts on what blockchain is and how does it kind of connect with with this whole kind of new world?
Sure, I would love to. So I think people are more familiar with all the Bitcoin hype lately, and that's been going on in the marketplace. But few people actually understand the real distributed, trusted algorithms in a trustless environment. So that's the whole premises, the foundation of Bitcoin, and that is the blockchain algorithm. And the blockchain algorithm, most famously, it is being utilized for all these cryptocurrencies, Bitcoin and Ethereum and Litecoin and so on and so forth. But the blockchain algorithm, the foundation of having trust in a trustless distributed environment, that can be utilized for many other dimensions and many other ways. So banks, for example, they are using this clearing houses, automated clearing house. So instead of having those manual processes and having centralized access to certain bank, it could be much more distributed, and machines actually verify the authenticity and endpoints of the transactions without disclosing the identity of the endpoint. So for example, if I want to transfer some money to you, then Bitcoin is very easy to, and there are tons of examples on the web online for that. But if I say, let's say I want to sell my house to somebody else, and none of us want to be disclosed of our identities in the transaction, and yet the transaction need to be foolproof, and it need to be authoritatively validated and compliant to all the local laws, one of the ways to implement is a blockchain mechanism. So think of it as a massive distributed database which takes care and behaves as if like I talk to the database saying, hey, make this transaction happen. And the other person also says like, yes, make this transaction happen, and the transaction happens. But underneath, it's a massive network of distributed systems. So thousands and maybe millions of computations, millions of storage and network activity, which actually orchestrates internally to make this transaction possible and have it in a reliable fashion so that it cannot be challenged. It's mathematically validated for the correctness purposes, and it's immutable. So it's not reversible. Nobody can fiddle it, and nobody actually owns it per se. So nobody has central uniform authority on top of it, which might allow them to change it later on for their own selfish purposes. So it's more of a having trust in an inherently trustless environment. That's the summary of blockchain.
So, the example you just gave, Biren, with the house and being able to kind of have that automatic clearance, is that going to be the case kind of, in the future of mortgages? Or is this, the example you just gave was like an exception? So meaning like, when I go to buy a house in the future, is it that I will be connected somehow to a blockchain and that transaction happens with the seller and we don't even connect, but we know that, everything's kind of been cleared? Is that what, maybe help me understand. I want to make sure I understand that dynamic.
Yeah, that's just like one example. So it's any transaction, give and take transaction, right? Like currency is most obvious one, like people spend money and people basically earn money. So money exchange is one sort of transaction, but house is another kind of asset. So I'm transferring house to something else, or you transfer any other kind of assets. So that domain is called like smart contracts, for example, right? So you add smartness to the contract. So I believe, yes, in the future, right now, escrow companies, they basically own that piece of transaction and they facilitate to a certain degree from identity prevention of buyer and seller and making sure everything is compliant, the title is clear and all that. But that is still a single party which is doing that. Single escrow company is taking care of that. So whenever there is a single entity doing anything, people are reliant, people are at the mercy of that single entity. So in the future, the world is becoming more democratic and much more decentralized. So people do not like the increased dependence on the single parties. So all such transactional interactions are bound to happen in a distributed manner so that there is no single entity controlling all the data flow and the validation and the compliance checks. But it's a massive computer network. It's no human intelligence again in there, so whom you can influence and have biased decision making and all that. So it's all just in a way dumb, but smart computers taking care of in a machine intelligence way about the whole transaction and orchestration of the transaction in a distributed manner. So same copy of the transaction is actually residing on thousands of computers at the same point in time. So even if somebody gets access or one computer gets hacked, the transaction at large is not affected. The integrity and cohesiveness of the transaction at large is not impacted as a result. So it's much more trustworthy in that sense. So I think all such give and take type of transactions, not just house and mortgages, but all such transactions in the future even including supply chain, like where I'm sourcing various parts to build a product. Like, how do I know the authenticity and genuineness of a given part from a given supplier? And so there are many other domains which are coming up with various use cases around this blockchain idea.
Couple more words.
Sure, yeah.
So the next one I have on my list here is RPA, so robotic processing automation. Hopefully I said that right. Share with us what that really means.
So RPA, I mean, I'm not a big fan of acronyms. So so RPA, one of my favorite fields, was drones actually. So RPA acronym is used for drones as well. It's remotely piloted aircraft as well. So, but I'll try to touch upon both like the robotics, automation, and drones in general. So I think the robots have been in the workplace for a long time, especially in the automobile and manufacturing and heavy industries and all, where I think there are various reasons. Either the manual thing was not safe or it was too monotonous. So I generally, in my keynote speeches, I tag them as like a 4D activities. It's dull, dirty, difficult, or dangerous. 4D tasks, right? So either it's a dull, mundane task, which no human being wants to do it, or it's a dirty thing, which nobody wants to get spoiled, right? In whichever connotation of dirty we can think of, right? Either physical or much more metaphorically speaking. So, or it's difficult, extremely difficult for humans to take care of that object, or it's dangerous from the safety perspective of human beings. So all of those things are being taken care increasingly by the machines, heavy machines in the beginning, which were manually operated, then automated machines, whom we call like robots, then intelligence machines, which are like making autonomous decisions based on certain machine learning, artificial intelligence paradigms, or flying machines, like whom we call drones. So drones are also being increasingly utilized. Initially, RPA term was designated for drones because of their presence and affiliation with the military. People were remotely piloting those aircrafts, obviously for surveillance and many other things. But drones are becoming much more viable and feasible in the commercial segment. Individual consumers are increasingly using them for photography, some difficult to take shots, aerial shots and videos and all the way to the commercial ecosystem where, like, let's say cellular tower inspections or aerial photography or coverage of live events, or like windmill inspections or many other kind of inspection to the live event coverage to other domains. They are being served effectively and cost effectively by this flying robots or drones. So I think the robotics is becoming much more integrated part of our day-to-day lives. Previously, we were unknown because it was primarily limited to the heavy industries and most of the population was disconnected from them. But lately, I think they are becoming part and parcel of our everyday lives. So, for example, Roomba, the robotic vacuum, I mean, it came into the household, right? So that's like a new kind of a robot which does its own vacuuming. And the consumer drones, which are flying all around us. So I think we are becoming more and more visible. And these flying machines or autonomous machines are becoming much more integrated into our daily lives, which was not the case earlier, a few decades earlier. But now I think that's the trend we are seeing.
Awesome. That's really, really helpful. My last word here is going to be fog computing. So tell us what that means. Yeah.
Cool. Yeah. So I think fog computing is a unique distributed computing paradigm for this IoT. Earlier, when I was describing IoT, it means putting the computation wherever it makes sense. So if you look back, the computing market has been doing the swinging between this centralized computation or the extreme edge computing. So from cloud computing to the smartphones. So in one case, you just put everything, all your compute and intelligence, everything in the cloud, so you capture all the data, everything flows into the cloud, and all the algorithms, intelligence is running in the cloud. So that's one extreme. Other extreme is, let's say, smartphones. Today, you collect the data locally and you process the data, the applications, various applications, games running inside your smartphone. They capture the data, they capture your face also, and then like Snapchat, they do various transformations on top of that, or Instagram. And so basically you capture the data locally, you process it locally also to some transformations before actually publishing to the cloud. So you do the processing on your smartphone. So those are like two extremes, either the cloud or the edge. What fog computing is, putting the computation anywhere in between, anywhere along this spectrum. So I think that's the most powerful way of defining fog. is you should not be limited to this either extreme, cloud extreme or the edge or device extreme. You should be able to run computational algorithms anywhere along the way. And very few people who are in the networking industry, they know that there are many, many networking hops along the way. When the data moves from my smartphone to the cloud, there are many, many hops along the way. It does not go in one stretch. So technically speaking, all of those hops are potential candidates for running computations. So in some cases, it may save your bandwidth. So instead of, let's take a practical example. If I have a temperature sensor, which most of the time during the summer months in California, it basically stays around, let's say, 85 degrees Fahrenheit. So it says 85 degrees. If I'm capturing the data, let's say every second from the temperature sensor, and all it says is, okay, 85 degrees, 85 degrees, 85 degrees, sometimes 86, sometimes 84, doesn't matter. And if I'm shipping all that data to the cloud, I'm utilizing my network bandwidth effectively for mundane purposes. It's like it's not doing any intelligent job for me. Instead, if I put a fog computing node, some sort of computing algorithm, somewhere in my home Wi-Fi gateway, for example, which takes care of like 3 of my temperature sensors, and it captures the data and says, hey, only if the temperature is out of the bounds, let's say the bounds are 80 to 90 degrees. So only if the temperature is out of those bounds of 80 to 90 degree Fahrenheit, only then report it up to the cloud. Otherwise, yeah, it's business as usual, nothing to report. I mean, why waste the effective bandwidth of the network for that, right? I mean, there's no purpose. I mean, it's not giving any more intelligence. It's just raw data, which is mostly noise. So that's one example of how fog computing can help you save the effective bandwidth by pushing the compute in my home Wi-Fi gateway instead of running that computation in the cloud. Now the entire pipeline between my home and cloud, that's free. It can be utilized for more meaningful purposes instead of just transmitting this dumb data set every second. So that's one example, one practical example of fog computing. And there are numerous other examples. There is, in fact, a fog consortium, which Cisco led in, and it's going on for, I think, for a couple of years already. And there are more than 50 companies and academic institutions are member of that. So check out on the Fog Consortium, Open Fog Consortium website as well. So that there are many more use cases of what fog computing is and what it could be utilized for, what kind of practical problems it can solve.
That's so helpful. So this was actually really, really helpful information and insights, Biren. I guess another question that I have is when you think about kind of the future and beyond, I know right now we're just in the beginning of 2018. What are some things that you see kind of in the future that people should be considering, particularly consultants?
Yeah, that's a great point. I think a lot of people are putting their predictions, analysis of 2017 and predictions for 2018. But I think what I like to see is more of an end goal oriented thought process. So in fact, I'm planning to write a blog post pretty soon on some 9 leadership attributes that everyone should strive to cultivate before 2019. So keep that goal of 2019, 1st January 2019 as the starting point, and what can you do in rest of the 2018 to cultivate those goals? And there are like 9 leadership attributes, and I can describe later on in that blog post in the detail, but it's more of a being an authentic leader, always thinking of, it's more of a following the ABCDEFGHI, the first 9 letters of the alphabet, being an authentic leader to being a business impact, always thinking in ROI terms, leadership, contemplative leadership, disciplined leadership, experiential leadership, fault-tolerant leadership, genuine leadership, helpful leadership, not only being selfish, but thinking about others, and finally, introspective leadership. How can you constantly think about improving yourself? So I think some of the attributes are needed for everybody, irrespective of whether they are just the beginning of their careers as consultants, or they are masters in the consultants, or they're working for somebody else, or they're having their own business. I think it's a universal appeal. And that's what I would like all the readers, all the listeners of the podcast to think about.
That's awesome. So hopefully we can get a link to that blog post, and go-getters, we'll make sure to post it on our website as well for you to check out. Those are really helpful because I like this conversation because we talked a lot about the technologies, but I love how you rounded it out and talked about kind of the leadership, the people skills that will really help kind of enable and drive this new world. So this is fantastic.
Exactly. Yeah. I mean, ultimately, it's all about people. It's all about ourselves. How can we be better selves of our own? in the future coming years, right? So it's constantly improving and learning and developing some new skills, either tangible or intangible, but adopting, learning new skills and making ourselves a better individual as we move forward.
Great. So I feel like there's just so much more to unpack and talk about, but we've run out of time, Biren. But if individuals are interested in connecting with you and learning more from you, how can people find you? Can you maybe share some of your handles online?
Sure, yeah. I'm active on LinkedIn. So LinkedIn is the best place. So LinkedIn, so /IN/Biren Gandhi, first name, last name combined in one word. And that's the same Twitter handle as well. So @Biren Gandhi. So those are the two obvious places to connect and reach out and follow and share interesting dynamics for the future.
The go-getters, thank you. I want to thank Biren for being on today's episode. Hopefully you'll come back, because I feel like this is an ongoing conversation, and people that are going to be great consultants in the future need to continue to be educated on all of these technologies. So thank you.
It is, and it's an educational experience for me also. So as I call it, it's a 3L. It's a lifelong learning for everybody, right? So I definitely am looking forward to coming on the show again in the future.
Awesome. So thank you, Biren, and thank you, my go-getters, for tuning in today. This is Christy Lindor signing out for the Misi Muse Unplugged Pop-Up Podcast. Here's to your journey to greatness.
Tune in every Friday for new episodes syndicated on iTunes, Google Play Music, and many more. Visit www.misimuse.com for more information.